6, which one?
Pick one.
Or pick one.
Well, on 67 and 74, I didn't get the B part of it.
Oh, all right, so if we look at either one of those, it's the same thing. So 67 is nice. It's not a word problem. They give you the formula, right? So to me, a word problem is when you have to create your own formula. That's a real word problem. So this one, part A is pretty easy. Let it be easy. So this is the height of a golf ball after so many seconds, right? So if it said how long until the golf ball hits the ground, what would physically be true? If you hit the ground, how high are you? 0, right? So then what would you do in the equation to solve part A? Would you plug a 0 in for t? If you plug a 0 in for t, what do you say? The time is 0. I don't want time to be 0. I want the height to be 0. So what would I set equal to 0? The height. So 0 equals that. And that's exactly what this section is all about, is solving equations that have t's or variables raised to a higher power. All right, so how are we doing there? So let's do that. Here. So part A says, how long until you hit the ground? So if I hit the ground, I'm 0 height off the ground. That's crazy. I'm on the ground. So take a second and solve that. Let's go ahead and get this out of the way. So number 67 and 6. Good little review. If you've already done it, just hang out for a second. All right, guys, so how do you solve this? What do you have to do?
16t?
Cool, man. You start to factor this. It's got a higher power than 1. So I can't get t's all together. I can't solve it like we did before. So if I take the 16t out,
6.
yeah, so you're left with 6 minus
T.
t.
That's it.
So then what do you do?
Yeah, we will say 16t would be 0 or 6 minus 3 would be 0. And that
So you get t equals
0.
0, or t equals 6.
6.
This makes sense because at 0 seconds, this is all about golf ball. So we're assuming it's basically on the ground. I know it's on the tee, but it's on the ground. Or maybe it is on the ground. Maybe it's on the fairway. I don't know if you play golf. I don't. But I know those words. And look at me. Here, this shows you I don't play golf. So, of course, before it's gone anywhere, it's on the ground. So that answer makes sense. I expect that answer to show up. But then, what does this mean? After I hit it, what does this mean?
6 seconds.
6 seconds later, it's back on the ground. Yeah, of course, it's going to go up. And in fact, what's it look like when I hit the golf ball? What's it look like? Be more mathematical. Parabola. It looks parabolic. I love it. Because what would this equation look like? It looks like a parabola. Holy shit. Right? So I love the idea of throwing something in real life actually mimics the math equation, because that's what math equations do. They're supposed to model what something looks like in the real world. So you can see that parabolic arch when you throw something. So that's part A. Part B is what the real question is all about. So Amanda's been very patiently waiting, saying, I didn't ask for that. So part B just says make a table for h equals 0 up to 6. And it makes sense now why they said 0 to 6. That's the part when it's in the air. And if you make that table of values, so you're going to make t 0 through 6, and you're going to see what h of t is. So you're going to plug a 0 in here, and of course it's going to make it 0. You're going to plug a 1 in here and see how high off the ground it is at 1 second. 2 seconds, 3 seconds. And you're just going to step back and say, what's the tallest height? Once you make your table, you can see it. You guys would probably be able to predict if at 0 it's on the ground and at 6 it's back on the ground. When do you think it's at the tallest, the highest point?
3 seconds.
Probably at 3 seconds. So you're going to prove that by making this table. Now in real life, you've got stuff like air resistance. You've got who knows what else is affecting the temperature, can affect the density of the air, which affects how high. It's crazy. So your equation will look a little bit more disgusting, but you would actually attack it the same way. All right, that last bit was not necessary for the problem. It's just Jeff doing his regular weird thing about connecting it to real life. All right, so that should help with the next question you had, right?
On 74.
74B. So you got part A?
Yeah. I just.
So let's see now, 74A. Can you guys put this together? It says rectangular floor has a length 4 feet longer than the width. All right, just take a second for me before I tell you anything else. This is number 74 in 6.6. Can you write? Can you label that picture for me correctly using the information that I've given you? Do it. Don't say anything. Do it. Bless you. All right, so tell me now. Which one's going to be just a single letter, the width or the length? Yeah, because the length is 4 feet longer than the width. I got to know the width first, so what do you call the width?
Okay.
That's crazy. So you can call it W, I don't care. Call it whatever you want to. All right, so the length has to be what? X plus 4. In fact, I think the problem said, screw them. They told you too much. I'm not going to tell you that much. They said let X be the width. I'm not going to tell you that. You can figure it out. Which one's got to be X, right? That's part of doing a word problem. So now if I label this thing, the width is X, the length is X plus 4. And then it says the area is 140 square feet. Take a second and try to write the equation down that represents that statement. The area is 140 square feet. And what's the area of a rectangle?
Length by width.
Length times width. It's crazy.
So X by X plus 4.
Area is length times width. Which part? Yeah, good. So what's the length? X plus 4. And what's the width? And that's supposed to equal 140. Cool. So that's part A. It's just to set up the formula, right? And then part B just says solve this. So when you go to solve this equation, it doesn't matter where the hell it came from. We know what's supposed to happen. What's wrong with how this equation's set up?
X is in front where it needs to be behind. Where it needs to be behind where it needs to be in front.
Oh, it doesn't matter. That doesn't matter. Because what would I do with it no matter where it is? Distribute. So what's wrong with this equation? What do I have to do first?
GC.
Subtract 140.
Yeah, what's it supposed to be equal to? 0, exactly. You got to tell yourself that. When you see a power higher than 1 on the x, it's got to be equal to 0. All right. If two numbers multiply by 140, what could the two numbers be? Almost anything. It's insane. But if they multiply by 0, you know something. That's why I want to make it 0, because then I know something. It's good to know something. All right. Like it feels good to know something. So to make it 0, you subtract 140. I like it. Cool. Is that cool? So these are, you have to understand how to solve an equation like this, because an equation like that could come out of anywhere. So it came out of this problem very easily. right? So I have to know how to solve an equation like that. So you subtract 140 and then you try to factor this. Cool. So somebody know how to factor that? What's up? Yeah.
14.
Yeah, 14 and 10, 11. So 14 and 10.
That's good. Positive 14 and negative
Good. Positive 14, so the middle comes out positive. And some of you guys do, you split at the middle term, but you don't need to. This is x squared plus 14 minus 10. What two answers do you get? Yeah, you get negative 14
Minus positive 10.
and x equals 10.
Yeah.
Now, which one of those makes no sense? Good. So the numbers work. If you're just talking about numbers, that's a valid answer. But if you're talking about, we're talking about freaking side lengths of a rectangle, that one can't be done. So this is the, what is this? The width. I love it. We got to remember, we're talking about a rectangular thing. My answers have to relate to those. So that's the width, 10 feet. And then the length you can figure out. Cool. What's the length? Yeah, how's the length? 4 more than the width.
14.
And how do I check what makes sense? What do I look at? How do I check to make sure this is right? What was the area supposed to be?
14 by
140. And if it's 10 and 14, what's the area?
140.
Holy shit.
That's
So you can always check yourself at the end. Okay. Anything else from homework? Yeah.
Number 66,
Oh, yeah. Yeah. So 66, still in 6-6. Oh, yeah, that's a good 66 and 6-6. Yeah, so they give you this. But in general, what is it about a right triangle sides? Yeah, that's E. As long as the biggest one is C, A squared plus B squared equals C squared. Fine. So you're going to have some foiling to do. Right? So what's going to be on this side? What's going to be by itself? Which one's the biggest side?
X plus R.
Yeah, because it's across from the right angle, right? So it'll be x plus 8 squared. I'm going to FOIL that bad boy out. And the other side I'm going to have x squared plus x plus 7 squared. So this is a really good example of math doesn't care what the specific parts of the problem are. There's a process to do it. So if you have a right triangle and you're talking about the sides, I can always use this. Whatever the sides are, you plug them in. It's going to take a little bit of work, but you know, should be used to that. Okay. Is it cool? I guess it's cool. Cool. Amanda? Yeah? Anything else from homework? All right. Okay. So, let's get back into chapter 7. We did a little bit, let's see. We actually got almost into 7.2, I think. Yeah, we got into 7.2. Cool. Almost. Oh, okay. All right, so let me set up a few processes, how to do these. And then I'm going to unleash you guys on several problems to work on together. So this is a good example of what to be careful about with this. It's very human to want, for example, to cancel the x squares. Why can you not do that? Why can't you cancel these x squares? Say again? Nope. Say again?
They use subtraction on a division problem.
Okay. So the thing you're thinking about when you said they're both positive, if I was adding them together, that's why they wouldn't cancel, because they're both positive. I'm not adding them together, I'm dividing them, right? But division cannot cancel, sort of like what you're saying. Division cannot cancel subtraction or addition. It can't do that. Okay? So what do you have to do first? I mean, division can cancel what? Multiplication. So if I can just make the problem have only multiplication in it, then I can cancel the parts that are the same, because then division would come in and do its job. Yeah, so how do you factor the top? Cool, 3 and 4. They make 12 and they add to be negative 7 if they're both negative. I like it. And then how do you factor the bottom? 5 and 4, kick ass. As long as they're both what? They got to both be negative to make negative 9. And here's what I don't understand. On your homework, you can constantly check yourself. You know what's supposed to happen. And some of you guys are just writing numbers down that only work for one thing. But negative 4x plus negative 5x does make negative 9x. So that makes sense. You can check yourself. You know what's supposed to happen. So you just take a second to make sure it happens. So now what can I do? Yeah, these x minus 4's just die. Because they're the same. It's this times x minus 4 divided by, okay, this go away. Because now I have multiplication and division. They cancel each other. So I end up with
X minus 3 over X minus 5.
bam. Alright, that's pretty simple. So the only thing they can really do in a problem like this is to give you kind of uglier factoring problems, right? They're going to throw some cubes in there. It's going to be some grouping. That's not ugly. Grouping. You just still have to be able to identify what to do. Your very first step is factor the hell out of everything. And then you kill, right? Yes, divide and conquer, Alan. It's very violent math. I love it. Kill. If you don't like violence, then I don't know. You took these too bad. So what do you think? Let me do this. Let's go to the next level here so you guys can handle this. What was a smart way to do a problem like this here? I don't know, Jeff, you don't have a problem. All right, give me a second. Let's see. What do you got, Jeff? So the not smart way to do this problem is just to multiply and then reduce at the end. Because then you got these giant numbers that you're like, what the hell goes into these numbers? The smart idea is to instead reduce first. I love it. And you can do a cross, you can do straight up and down, right? You just can't do like this. One's got to be on the top, one's got to be on the bottom. So does anything cancel straight up and down? Straight up and down, nothing cancels, right? So, but across, what happens?
We can call 15 root 15 by 3.
Well, actually, what happens? 15
By 3.
goes into 45 3 times, right? So 15 goes into 15 once, 15 goes into 45 3 times. So this is old news. This is nothing new. You should be used to this. And what happens here? What's beautiful there?
19, 1, and 2.
19 goes into 19 and 38, kick ass. And now it's easy. 1 times 1, 1. 2 times 3, 6. All right, so now, of course, that's not the problem you're going to get, because that's Math 88 shit. Let's look at Math 90 shit. Right? Math 90, you're going to get variable expressions. So the only difference between this problem and the kind of problem you're going to see for this is you're going to have two of these things sitting next to each other. And you still factor, but now you got all these different places to kill. Right? So let's see. Just to give my tired brain a rest. Let me take one out of here. That looks gross. Let's do that. Oh yeah, let me show you. This is a good skill to have here. All right, let me show you something that relates to problems that they gave you back in chapter 6 as a really good skill to have. Help me out here. In order for this to reduce at all, in order for this to be able to be simplified, what's got to be, do these reduce? Hell no, because what's the top got? 3x plus 1. What's the bottom got? 2x minus 3. They ain't got nothing the other one's got, right? How are we doing there? Neither one of them has an x. Neither one of them has a 2. Neither one of them has a 3. This one's got a 3x plus 1. This one's got a 2x minus 3. So they have nothing the other one's got. So think about this. This is kind of cool. In order for this to have something happen, what must be true about this, for example?
It has 2x minus 3.
Yeah, it probably has to have a 2x minus 3. Right?
Yeah.
Or these two have something in common too. But I'm going to start with that because that's probably true. And this sort of feels like there's that first chunk of a homework. I can't remember what section it was in. And they had these blank spots and you had to fill in with a 3 and a 4 or whatever. If you've done the homework, you know what I'm talking about. You had to put 2 and a 6 or whatever. And some of you guys didn't really get the point. But if they give me some information, so if I assume, now go with me, please, dear God. This is going to, and how would I do this officially if you don't understand what I'm about to say? 6 times negative 2 is negative 12. Factors that make 11, that's pretty simple, right? But what I'm about to do is a lot quicker because I have more information now. So if I say 2x minus 3 is a factor of this, why won't that work? Could that work? Can I make 6x squared?
Yes.
Yes. What would I have put here to make 6x squared? 3x.
Yeah.
Now what would I put here to make negative 2? I can't. Do you guys see what I'm saying?
Yeah.
So the top won't work quickly. I'm going to have to just attack it like normal. Right? But let me check to see if these are going to work quick. So the top I've got to do like normal. I've got to just factor it out. What about the bottom? What if I assume it's got a 3x plus 1? Well, how would I make it 3x squared? Yeah. I put an x there to make 3x squared. How would I make it minus 4?
3. 4.
Minus 4. And let's check. Plus x minus 12x. Is that right? Plus x minus 12x. Is it positive 11x? No. Man, they were really evil to you in this problem. I picked an evil problem.
Yes. No. Just change.
Oh, I see why.
Change the negative numbers.
All right. Now let me do this. All right. I just realized why I picked an evil problem because I mixed two problems together. So you guys try this here. All right. Let me do one of these with you. So here's what it is. All right. So real quick, can this reduce? Can these two reduce?
No.
No, they can't. Right? I can't take anything out of this. That's also something I can take out of this. I can't take anything out of either one of them. So, and they're not the same as each other, so nothing reduces there. All right. Let me do the top with you, and then I want you guys to try the bottom out. And if you don't like this method, you don't have to do this method because, like I just showed you, it doesn't always work. All right? But what's got to be a piece of this?
6x.
Yeah, probably 6x minus 1. And then what has to be in here to make 6x squared?
X
Yeah, I have to have an x here to make 6x squared.
plus 1.
Careful. To make a minus 2.
Plus 2.
Yeah, it's got to be plus 2. Now let's check it. Let's check it. What do I have to check now? What did I just make work? I just made the first term work, and I made the last term work. You guys with me?
For now, I'm so.
All right, let me try again. Does it make sense? Why did this work? Because 15 is a part of 45, right? Okay, and I can just see it is. But here, I can say, well, in order for this to reduce, that would have to be a part of this. Is that first step understood? The same way over there. 15 is a part of 45, that's why it worked, right? So if 6x minus 1 is a factor of this, let me write it down. What would the other piece have to be? And then I'll check to see if it really is true. So if that is a piece of this, what would have to go here to make it work for the first term? What would make that 6x squared? X. All right. Cool. Good. It's not that hard to understand. And the reason it's easier is because we have more information. It doesn't always work, but it will almost always work for the problems we have in the book. Because they're just like practice problems, right? They probably will always work. And to make negative 2, what would I multiply negative 1 by to make negative 2?
Plus 1.
Negative 1 times 1 is 1. Negative 1.
2, yeah.
2 to make negative 2, right? So I made the first piece work. I made the last piece work. I got to check to see if the middle piece works. So what do I get for the middle piece? 6 times 2? 12x. Minus x is?
11x.
That's the answer. That's how you factor the top. Why was it easier to do that? Because I had a piece to guess. I had a good guess. And if it didn't work, I would erase it and do 6 times negative 2 and do it the old-fashioned way, right? So how do you do the bottom? What am I going to assume is a part of the bottom? 3x minus 1. Because if it is a part of the bottom, then they'll cancel. I don't know yet if it is. It might not be. What would this be to make it true? Yeah, 3x times x is 3x squared. Yeah, and negative 1 times 4 is negative 4. Let's see. 12x minus x is 11x. So that is true. That is right. If it wasn't 11, I would erase it and just do 3 times negative 4, do it the old-fashioned way.
So this doesn't work all the time?
Doesn't work all the time.
Why?
Like I just showed you. I had the wrong things written down here, right? And it didn't have it as a part of it. It might not work. Maybe these don't cancel. Maybe between these two they have something that cancels, and that's all that cancels. Maybe. But it's a really good guess that that's going to go into this, and that's going to go into this. It's a good guess. And if it isn't true, I go, oh shit, I just got to do it the old-fashioned way. Oh well. If you don't like this at all, you never have to do it. But it's a really good kind of skill to have. So just to make sure that this does work, if I do this, what I'm calling the old-fashioned way, how do I do this? Just how do I factor that by itself?
So you do 6 times 2.
6 times negative 2?
Yeah, and also you get negative 12. Then 11. Oh, I mean,
12
then
is
you have
one.
to figure out what it is.
It's got to be, yeah. Since that's 1 off from this, it's got to be this and 1. And which one's got to be negative?
12 and 1. Over the 1.
The 1, so that the positive one is bigger, right? To make the middle term positive. So then I can split up the middle term. So 6x squared is the same, minus 2 is the same, 11x is 12x minus x. What comes out of these?
6x.
What comes out of both of those? Negative 1, and I know it's got to be that because I want these to be the same. I got to take the negative out, so this becomes positive x plus 2. So the last step would be
6x minus 7 times x plus 2.
right. So I'm not saying that you suddenly have to do it the way that I just did this. I am not saying that. I'm saying that's really kick-ass cool, and it's going to be very useful through all of chapter 7. The kind of problems we're going to do, they're going to be hints in the problem as to how something factors. And that's you try it. I'm not saying it's guaranteed to work all the time, but hell yeah, I'm going to try this first. Because if it works, I'm done. Bam. And then what can I... So you can still do it this way. You can still do it that way if you don't like this at all. So what happens now? What can I do? Is everything factored? Yes, everything's factored. So now division can come in and kill something. Because it is the opposite of multiplication. So what dies?
3x minus 1.
Good. The 3x minus 1s die. 6x minus 1s die. And I'm left with...
X plus 2 over x plus 4.
Cool. I like
Would
Yes.
that be easier for like if you were factoring something huge? Let's say if the middle number was like 374.
Oh, hell yeah. Hell yeah. I'm going to use whatever hints I have. And if I'm unlucky enough that it doesn't work, I just got to do it this way.
Okay.
But yeah, I'm going to try that way first. Right? So if you go back and look at that earlier homework where they had that section where you had to fill in the blanks and you had trouble with it, this is all it is. Just make the parts work. Right? If that's a 6, that's got to be a 1 to make 6. If that's a -1, that's got to be a +2 to make -2. And then you check the middle term to make sure that's right. That's all. All right. And again, if you don't like it, you never have to do it. You don't have to. It's just another thing you could use.
Aren't the answers different? The two ways to do it?
Definitely not. This was the same as this, wasn't it?
Yeah.
Yeah, and if you do this, how would I do that? Same way, right? 3 times -4 is -12. To make 11, it's still going to be 12 and -1, right? So it'll be, I'm just going to do this real quick. 3x squared plus 12x minus x minus 4, using these numbers here, right? So I can take a 3x out of there, and a -1 out of there, and I get x plus 4 times 3x minus 1. Bam. I like it. So you can't get a different answer. So if I said factor 18, you cannot get a different answer than him if you go all the way. If you start with 2 times 9 and you start with 3 times 6, I don't care. You're both going to end up with 2 times 3 times 3. So factoring, you can't get a different answer just because you did it a different way. You can't. Unless you make a mistake. And then anything can happen. Right? All right. Let's try another one. Thanks, Andrew. Let's see what else is weird. Oh, yeah. All right, let's do that. Try to get as far as you can on that problem. And just to stop anybody who's going to do this, you definitely don't want to write that 3 times and multiply, because the whole purpose here is to factor everything. So what's true about this? The top here, it's already factored, so you leave it alone, right? And of course, this guy's got nothing, so you're just going to focus on the parts that aren't factored yet. Attack those. Let me catch up to you guys here. How do you factor the bottom of this?
X minus 1, X minus 1.
I like it. How do you factor this one? All right, so now you kill what you can. The minute somebody's dead, he's gone. So for some reason, I always have somebody that kills both of these. Now, how could that be true? Because once one of them's dead, what kills this one? This one does. Is there another one left to kill that one? No, so he's still there. He's like, ha ha. All right. He was standing behind the other guy, so he's still alive. Right. So all that happens here. How many X minus 3s can I kill?
2.
Yeah, 2 of these kill, die, and leaving how many of these?
1.
All right, cool. Does everybody see that? Let that be simple. I had 3 of them up top. There are 2 down below. So 2 kill each other, and there's 1 left up top. Why up top? Because that's where most of them were in the first place. That's where the survivor's going to be. So what's left? And I don't know if it's true for you, but I always felt it feels good to take something that looks this disgusting and make it look a bit less disgusting. Right? It's kind of nice. You're cutting out the extra crap you don't need. All right, maybe. Okay, let's do this then. Let me shut the hell up for a bit. In the blue book, I'm going to put it over here on the board, on the overhead. It's page 132. I brought some extra copies